only question in here is just that probability is just that because this is not a Z-score, obviously.
No.
And is there any other way that we can remember how to calculate the probability?
No.
I didn't see it on my notes, but maybe let me check. That's a standard deviation. And we are sure that P in the hat, it is a probability. Isn't P in the hat a true population?
P in the hat stands for sample proportions.
Sample proportion. Didn't we do this yesterday on the group meeting? Hold on. Hold on. I think we saw it yesterday in the thing what it says. Hold on. True proportion. Well, in yesterday's in the group meeting says that P is only the true proportion. So the P in the hat should be the sample proportion, as you mentioned.
Yeah.
But is that actually the probability? The sample proportion is equal to the probability?
No.
That's what it gets me, because it's not something, you know, the exercise actually is asking for the not for the proportion, for the population. I mean, for the, what was it? So for some reason, I think we're using the wrong formula. For the probability. So we're actually not looking for P in the hat. So X divided by N will not apply on this one. I think the population.
We can go back to when we're finished with the group meeting, I guess, because we still need to talk about the group project too.
I think that the population is just the 45%. But I don't know. Well, we can do the start with the thing for the group meeting, and then we can come back to this one in case we have any question, or send an email to your teacher. All right, let's do 17 then. So start the meeting, Ellie.
All right. All right. Does everyone have their quiz open?
Yes.
Okay, number 3, the symbol for the true population proportion is, and then I just put P.
The last one, right?
Yeah.
Hold on one moment. Everybody agree with this?
Yes.
Okay, the next one is number 4 for question 4 and 5. Suppose N equals 100, P equals 0.25, and P hat is equal to 0.10. The requirement for constructing a confidence level interval satisfied, true or false?
What number are you on?
4.
45.
So
you just have to multiply.
The requirement.
Yeah, the requirements. You have to multiply 100 by 0.25 and make sure it's greater than 10. And then you have to multiply 100 by 1 minus 0.25 to make sure it's greater than 10.
So 100 times 0.25. That will be, I think I did it already. Hold on. Yeah.
You should get 25.
So 100 times 0.25 will be 25, right?
25.
Mm-hmm.
So this one is good.
Yep.
So let's do the other one. The other one you say will be the 25, right?
The other one should be 100 times 1 minus 0.25, which should be 75.
Let's see, 100, 1 minus 0.25. So it will be 75. So it does, right?
Yep, so it's true.
Yeah, because both are greater than 75, so it's true. All right, the requirements for conducting a hypothesis test are satisfied. So it says that the requirements for the hypothesis test,
I think they're just the same requirements. I'm pretty sure.
I think so.
Let me look in the book real quick.
In one of the videos, it shows the requirements for where am I going? It's not this one. Well, in the video number 3, they say the steps to hypothesis testing, but I don't see no hypothesis in there, so I will go with the same as you mentioned, the n's greater than 10, and the other one.
It says that, I found this thing that says the requirements to check for one proportion hypothesis testing. It says a sample is obtained from a simple random sample. The requirement of doing a hypothesis test is NP greater or equal to 10 and N in parentheses 1 minus P greater than 10.
So it will be true.
Then we can assume that the distribution of P with a little hat is normal.
Yeah, so it will be true.
It will be true.
All right, number 5 says a study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Use this information for questions 6 through 8. 6 says find p-hat, the point estimate of the proportion of first-degree murder defendants who were found guilty in the state. So you would just do x divided by n, which is 45 divided by 60. Which is,
say that again?
So when you're finding p-hat, you just do x, which is the number they give you, divided by n, which is both sides. In this case, it's 45 divided by 60, which is 0.75.
0.750, right?
Mm-hmm.
Yeah, that's what I got.
Okay.
So for number 7, I say create a 95 confidence interval for the true proportion of first-degree murder trial in this state. The verdict is guilty. So for this one, you use the formula for plus and p-hat, plus, minus, and so.
Yeah.
And the z-score for the 95 interval and is the confidence, 1.96. And then you will get the answer for, I got the second one, Ellie. I don't know if you got the same.
So did I, yeah.
Did you?
I'm doing the math now, but for the first one, did you get 0.75?
Yeah.
For number 6? Okay.
Yeah.
So for number 7 is the second option, right?
So this is the inverse of things for number 8.
That one is easy.
Yeah.
For number 7 again, is the second option?
Yeah.
Okay, I didn't hear. So for number 8, that will be decrease, right?
Yeah.
I always have to read, but I think so.
Yeah, in the video, the guy give us 2 rules, so that way it was pretty easy for me to do this one.
Because I
So
know
who wants to
it's
do?
the inverse. Like with one increases, the other one decreases. But I always forget, so I have to get the notes.
Well, when he's talking about the samples, yes. But when it's about the confidence interval, it's a little different. It's not that the one goes up, the other one goes down. If you increase from 95 to 99, then
This one's talking about sample size.
Yeah, but if it's sample size, I think it is. All right,
So
who wants to read number 9?
So if the sample size increases, then the confidence interval decreases?
Let me check. I highlighted the 2 rules. Oh my. It says that as confidence increases, interval increases. As sample size increases, interval decreases.
So it's decrease.
That's the
Can you
rules.
say that again one more time?
Yeah, the guy say,
Sorry.
as confidence increases, interval increases. I guess the confidence interval. As sample size increases, interval decreases.
All right.
So that those 2 basic rules that I really pay attention. I even highlighted because I know it will always come up on these kind of things. Maybe it was over when we did the the scanner saying on previous lessons. So maybe, but I was like, okay, let me write it down. All right, who wants to do number 9?
I'll read it. To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1/2 is the smallest in B, and both requirements still be met. So
this is the same as we did with the N, right?
Divided by 1/2. Yes, it's 20.
Yeah, I got 20, yes. Maybe I did it right. So the other one will be, the number 10 is 100, Ellie?
Yeah.
Yeah.
100. And it is number 9.
Good. Thanks, God. All right, so 10 is 100. All right, Alma, can you read 11?
Sure. It says for questions 11 through 16, use the following information. For the water quality study in the reading, about 60% of the microinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance level of alpha equaling 0.05 with the following hypothesis. The first one is equal to 0.6, and the alternative is less than 0.6. They collect new data, and this time n equals 80 and x equals 38, indicating good health. The condition for the hypothesis test are satisfied, true or false.
So we again do the Eggman and the N formula, right? All right, let me see. No, that's for 12, but for 11, we will have to check if both of the sides are equal.
But because it is 0.475, it is less than 6. 0.6.
Say that again,
No?
So you don't have to be by the 0.6, right? You just got to be by 10, right, Ellie?
By 10.
It just has to be greater than 10. So
That's
you have
it,
to
yeah. You
you
gotta
have to
still
find
apply.
P first, and P is 38 divided by 80.
Thank you.
It is.
And you get 0.475, like Zoila said. And then you have to multiply 0.475 by 80, and it's greater than 10. But then you have to check the other one, so you have to do 80 times 1 minus 0.475, which is so greater than 10, so it's true.
It's true. I don't understand the second part. So after we get the 0.475, we multiply that.
Yeah, you get 0.475 for p hat, and you have to multiply it by n,
Oh, by n.
which is 80.
By 80.
That's the first requirement. And then the second one, you have to do 1 minus 0.475, and then you have to multiply that by 80 for the second requirement.
So for one side will be 42 and the 4 and 0.475 divided by 80. No. The first one is 38 divided by 80, right?
You do for what?
For the end on the first side. For 11 to see if it's right.
Find P
You have to divide it by 80, but what was the top number?
38.
Top is 38.
38, okay. 31 divided by 80.
Yeah. And you should get like.
So it doesn't, right?
No, it does. 38 divided by 80 is 0.475, and that's P
But that's
hat.
not greater than
And
10.
P hat times n has to be greater than 10. Or C is 38. That's greater than 10.
38 times what? Times 80?
So P hat. So P hat is x over n, right?
Correct.
And if you look at 11, right above the number 11, it says that n is 80 and x is 38.
Correct.
So your p hat equals 0.475. And the first requirement says that your sample times p hat has to be greater than 10. So your sample, which is 80, times your p hat, which is 0.475, is 38, and 38 is greater than 10.
Okay, got it.
And then for your second requirement, you just do 1 minus 0.475.
Multiply by 80.
And then you multiply by 80.
Yeah,
Yep.
that's 42, so that's good. Okay.
All
I
right.
didn't get it the first side. Okay.
All right. Number 12 says, what is p hat? And we just found p hat 38 over 80, so 0.475. Did everyone get that?
Yeah.
Yeah.
It's 0.475.
Yeah.
Mm-hmm.
And then you
So
guys
for the
just
C,
need to-
for the 13,
yeah.
you can either do it on the Excel or you can do it by hand. But I did both, and both gave me the minus 2.282.
Yeah.
For the z-score?
Uh-huh.
Yeah.
Minus 2.282.
He's not going to come today. Say that again.
Minus.
Minus 2.282. So actually, if you use the same, you put in the information that you got on the beginning of the exercise, and you put it in the Excel, it will give you the p-value. So if it will give you the z-score, the p-value, and the p-value will be 0.011.
Yeah.
So it is very useful once you get all the information. So since the p-value is, what was the limit? 0.5.
So you reject it because 0.01 is less than 0.05.
It's less, right?
Yeah, it's less, so you reject.
So you reject. So we have insufficient, right? I mean, sufficient, right?
There's sufficient, yeah, to conclude that it decreased.
So it's the first or
The
is
first one.
the first one, right?
First one, yeah.
That
Yeah.
is sufficient.
What was 14?
0.011.
0.01?
One.
Uh-huh.
This wasn't
point-
about.
0.011?
Uh-huh.
Yeah.
Okay.
Are we ready to
All
submit?
right. Yeah. You guys should get 100. I got 100.
You have a count.
Weird.
You submitted already.
Just for the third one, the third question is the last one, right?
Yeah.
Yeah.
And the 4 and the 5 are through the both.
Yes.
Alright,
Alright,
I'm
so-
just making sure before I submit it.
You're good.
For
I'll
the
just
6,
keep
you
talking.
say
So Sat,
0.75. Do we add a 0 at the end in order to have 3 decimals?
Yes.
it doesn't matter.
Oh, okay.
Well, it says round to the 3 decimals, so I don't really know if it affects it or not, but I just put it.
Okay.
Yeah.
Number
sure.
10 is 0.100, right? Or it's no, it's a 100. It's a whole number. Okay, yeah.
Yeah.
I can see the little numbers in here. Okay, let me submit
And the
it.
9, it is a 20, right?
Yes.
Okay.
Yeah.
Yeah. All right. We're done with this. So take us the recording, Ellie, so we can talk about the project.
Alright.